Let's see the numerical. An analog voltmeter uses external multiplier settings. With a multiplier setting of 20 kilo ohm, it reads 440 volts, and with a multiplier setting of 80 kilo ohms, it reads 352 volts. For a multiplier setting of 40 kilo ohms, the voltmeter reads. It is asked in GATE 2012, and here are the options. So how do we solve this? First of all, extract the given data. In this it is given the voltmeter uses the external multiplier setting. That means a voltmeter is there and one series resistance is connected, that is nothing but the series multiplier. Fine. So here first condition is given, that is the multiplier setting is given 20 kilo ohms, and for that the voltmeter reads the 440 volt. Second condition is given, the multiplier setting is 80 kilo ohms, and in that case the voltmeter reads the 352 volts. Now we have to find out the voltmeter reading for the third multiplier setting, which is 40 kilo ohm. So what should be the voltmeter reads? That means the reading of the voltmeter we have to find out for the third case. So this is the given data. From this complete numerical, you can draw the diagram like this. This is nothing but the resistance in series with the voltmeter. This resistance is nothing but your series multiplier, which is denoted by the RSE. The voltage across this meter, that is the voltmeter, it is denoted by Vm, and the internal resistance of this voltmeter is denoted by Rm. We already know all these parameters. And the current which is flowing from this complete series coil, or you can say the series branch, that is the nothing but the meter current denoted by Im. And the complete voltage across this load is nothing but the complete voltage denoted by the capital V. So it is given first condition, that is first multiplier setting, that means the first RSE value is given 20 kilo ohm. For that the voltmeter reading we are denoted by Vm. So for the first it becomes Vm1, it is given as 440 volt. Similarly for the second it is given 80 kilo ohm resistance and the voltmeter reading is 352. We have to find out the voltmeter reading for the third condition when the multiplier setting is 40 kilo ohm. How we will find out this? You can see in this diagram, consider this diagram only. From this we can write down that Vm is nothing but Im into Rm, that is the voltage is equals to current into the resistance. So for this voltmeter reading, the current which is flowing, that is nothing but the Im, and the meter resistance is given, that is the Rm. We can write down that equation, that is Vm is equals to Im into Rm. And we can write down one more equation, that is the complete voltage, this voltage, that is the load voltage. Across the load, what will be the voltage? We can write that Im into RSE plus Rm into Im. This is nothing but the complete equation. So we can write down here, we can take the Im as the common and write down as Im Rm plus RSE. This is nothing but the voltage across the complete load. We have to take the ratio of V by Vm, or you can say Vm by V, any ratio you can take. Here we are taking as V by Vm ratio. Substitute the values of V and Vm. We will get this equation. Solve this equation. Here Im will get cancelled. So you will get the simplified equation as V by Vm is equals to Rm plus RSE divided by Rm. Again you can simplify it, divide this right hand side by the Rm. So we will get V by Vm is equals to 1 plus RSE upon Rm. This is nothing but one equation. From that find out the value of this load voltage, that is nothing but the capital V. So the equation becomes 1 plus RSE upon Rm into Vm. This is nothing but the equation of the voltage across the load. Why we have to find out this value of voltage here? Because whatever may be the multiplier setting, according to that the voltmeter reading will get changed, but the voltage across the load will not get changed. So here when RSE is changed, your Vm will get changed, but the load voltage will not changed. So therefore, we have to find out the value of this load voltage first. Fine. Here, for the first condition, what will be the value of this load voltage becomes? It becomes RSC 1 and VM 1. The resistance across the voltmeter will remain the same. Here, what is changing? The multiplier setting. Multiplier setting, that is nothing but the RSC. That setting will get changed. According to that, your voltmeter reading will get changed. But the meter resistance will remain the constant. So here you can get the equation for the first condition as V is equals to 1 plus RSC1 by Rm into Vm1. We know the value of RSC1 and Vm1. Substitute that values and you will get one equation that is equals to V is equals to 1 plus 20 into 10 to the power 3. Why 10 to the power 3? Because it is 20 kilo ohms divided by Rm into 440. Denote this equation by 1. Similarly, we can write down for the second multiplier setting equation. For that, what value will get changed? That is nothing but the series multiplier resistance. Resistance multiplier will get changed and the voltage across that meter will get changed. So the equation becomes V is equals to 1 plus RSC2 divided by Rm into Vm2. Now again substitute the value of RSC2 and the Vm2. The equation we will get as V is equals to 1 plus 80 into 10 to the power 3 divided by Rm into 352. This is equation number 2. I had already told you the voltage across the load will remain same. So here this V is nothing but the voltage across the load, and in this equation also this V is nothing but the voltage across the load. In both the cases the voltage across the load will be same. So therefore we can directly equate equation number 1 and equation number 2. So equating equation 1 and 2, we will get this equation. Now in this complete equation, what is unknown only here? That is the resistance across the meter, that is denoted by Rm. So from this equation we can find out the value of the Rm. Simplify the equation and we will get the value of Rm as 220 kilo ohms. This is nothing but the meter resistance value Rm, that is 220 kilo ohm. But what we have to find out? We have to find out the value of the meter resistance when the multiplier setting, that is the third multiplier setting, is there. From this equation we will get the value of Rm. Now substitute the value of this Rm in equation number 1 or in equation number 2. So we will here substituting in equation number 1, we will get the voltage across the load that comes out to be 480 volts. So here what will be the unknowns? Two unknowns, that is the voltage across the complete load denoted by V and the meter resistance which is denoted by Rm. Both are now, we are getting both the unknowns. Now substitute this V and Rm for the third condition. Now for the third condition, what will be the equation of the voltage becomes? That is nothing but the voltage across the load becomes, it will be V is equals to 1 plus RSC3 by Rm into Vm3. Here the voltage across the load will remain the same for all the conditions and the resistance across the meter will also be remain same for all the three conditions. And what is changing? Only the series multiplier resistance, that is nothing but the RSC, and according to that the voltmeter reading will get changed, that is the Vm3. Now substitute all the values in this equation what is given in the complete numerical. And what we have to find out? We have to find out the value of the Vm3. You can simplify this equation for the Vm3. It becomes Vm3 is equals to V upon 1 plus RSC3 by Rm. From this equation all the parameters are known. Substitute all the values and we will get the voltmeter reading for the third multiplier setting as 406.15 volts. This is nothing but the voltmeter reading for the third condition for the third multiplier setting. So from that we can choose the correct option. So here the correct option is option number